ultimate route to JEE success with JEE Test Prep app by Extramarks, adaptive testing platform, India's top faculty, micro-scheduling, live and recorded sessions, doubt-solving sessions, national level weekly tests, analytics and reports. Download the app now.
Hello students, today we are going to discuss about the next topic, which we call it as Archimedes Principle. In your school level, I hope so you have been studied about Archimedes Principle, that is simply Eureka Principle. So that we are going to start now. So let us start the session. The topic is mechanical properties of fluids and Archimedes Principle in that. So next one is Archimedes Principle. It is very clear. So we will see here, when a body is dipped in a liquid, it experiences an upward force called buoyancy force, which is equal to the weight of the liquid displaced. Means if there is a container, inside that liquid is there, fully filled liquid, then in that if I dip one iron solid sphere, then somehow the liquid will expel out. So that liquid, if we collect into a bowl, then that liquid weight is nothing but buoyancy force. You can see here, this is called as buoyancy force, upward thrust, which is equal to the weight of the liquid displaced. So this weight of the liquid displaced due to this solid sphere is nothing but the buoyancy force. And now that is nothing but m into mass of the liquid into g. Mass of the liquid is density of the liquid into volume into g. So that is what here it was written. Now if the density of the solid is rho, buoyancy force can also be balanced like this. That is, upward force should balance downward force, that is weight of the body. So then you will get this expression. Now if an ice cube of density rho and side length a is floating in a water and the density of water is sigma, find the height of the ice cube above the water. And if it is submerged and then released, it will oscillate obviously up and down. Then what is its time period? So let us assume that ice cube is this, only outer part is h height, then obviously inner part which is inside the liquid column is a minus h. Then you can see when it is floating, upward force should balance downward force, and you know that should be equal to weight of the liquid displaced. So for that we have to calculate what is the volume inside the inside the liquid. So that is a square into a minus h, because this much is there. The volume of this will be L into B into H square. So obviously bottom is square, the L square, height is A minus H. That's it. So buoyancy force is density of the liquid, volume of the liquid expelled into G. Volume of the liquid is how much? Volume of the solid inside. That is why I calculated here, substituting here this much. Now if we go for further step, as per the law of flotation, upward force should balance downward force. Means what? Buoyancy force should be equal to weight of the body. What is weight of the body? Density of the body into volume of the body is cube, so a cube into g. So equating, you can see there by solving this expression. Okay, this is the part of the ice which is outside the liquid column. Now suppose ice we had been given a small disturbance, so it will oscillate. When it was oscillating, there exists a time period of oscillation. So buoyancy force will be more than the previous buoyancy force. Then net buoyancy force will be upward force minus downward force. Then this is that. So which is perfectly in the form of kx, where k is spring constant. And maybe you might be done this. Spring constant time period is 2 pi root m by k, where m is the mass of the block, here mass of the ice cube. K is the spring constant, we got here rho a v squares. So sigma a square g. So then after solving, we will get this. So you can see here, sigma means density of the liquid, rho means density of the body. Density of the body by density of the liquid is called as specific gravity. So please try to understand, this is specific gravity. So in future classes we are going to study about the simple pendulum in simple harmonic motion. There the time period of simple pendulum is 2 pi root L by G. So you can easily extract this just by multiplying in the root specific gravity. Now, some solved examples. Let us take kerosene and water together, and an ice cube is having a relative density 0.9 is submerged like this. V1 is the volume inside the kerosene, V2 is the volume inside the liquid. Then what was the fraction they are asking? V1 by V2. So as of you know, volume of the ice cube is V, then the V2 I am calculating. V2 is nothing but the volume of the ice cube in the water. V2 will be V minus V1 as per the figure. Now, buoyancy force is equal to density of the liquid displaced. Buoyancy force due to water is this much. Then law of rotation says that upward force should balance downward force. Then upward force is this much. Downward force is weight of the ice cube. Then after solving, we will get this much. Practice this. So volume of the fraction of ice in kerosene is 1 by 3, then obviously in water will be 2/3. Thank you very much. Till then, happy practice.
For more such videos, please like, share and subscribe to Extramarks Test Prep YouTube channel.